Hey everyone, welcome. Sometimes math feels like a mystery, and today we've got a great one. We're going to be detectives, trying to track down this mysterious number k. We're going to solve it together, so let's jump right in and start looking for clues.
All right, so here's the puzzle we need to crack. We're looking for the smallest positive integer k, a whole number, that makes 392 times k a perfect multiple of 396. Now, that might sound a little complicated at first, but trust me, the solution is actually super elegant and all the clues are right in front of us.
The cool thing about this is that it's not about just guessing numbers. Nope. The answer is literally hidden inside the DNA of 392 and 396. All we need to do is figure out how to read that DNA, find the right key to unlock the secret.
Okay, so before we dive in deep, let's make sure we're on the same page. Every good investigation starts with the basics, right? So what does it even mean to be a multiple?
It's actually pretty simple. If 392k is a multiple of 396, it just means that when you divide them, make this fraction, the answer has to be a nice, clean whole number. No fractions, no decimals left over. That's it. That's the entire goal. So, the big question is, how do we guarantee we get that nice whole number? Well, this is where we pull out our secret weapon, our special detective tool, prime factorization. It's like having a pair of X-ray goggles that let you see what a number is really made of.
And what are these building blocks? They're prime numbers. You know them, 2, 3, 5, 7, and so on. They're kind of like the Lego bricks of the math world. They're the most basic pieces, and you can't break them down into anything smaller.
And here's the really cool part. Every single number, has its own unique recipe of prime numbers. It's like a fingerprint. So 392 and 396 each have their own secret recipe, and our job is to figure out what those ingredients are.
Okay, we've got our tool. Let's get to work. Time for the investigation to really begin. We're going to take apart 392 and 396 and see exactly what primes they're built from.
So, when we do the factorization, we find that 392 is basically 3 2s and 2 7s all multiplied together. And 396, that's 2 2s, 2 3s, and 1 11. These are the raw ingredients of our puzzle.
Okay, let's put these side by side. For a fraction to work out, for the top to be divisible by the bottom, the top number, 392k, has to have at least all the prime ingredients that the bottom number, 396, has. So, what's missing? Well, 392 has plenty of 2s, that's fine, but look, it's got no 3s and no 11, and that's where k comes in. It has to fill in that gap. And just like that, we're at the big reveal. K isn't just some random number, it's the missing piece. Its entire job is to supply the prime factors that 392 is missing. Let's see exactly how that works.
So let's rewrite our original fraction, but instead of using 392 and 396, we'll use their prime factor recipes. Now, I know this might look a bit messy, but doing this is so important because now we can see everything. All the components are laid out right in front of us.
First thing we can do is simplify. It's just like simplifying any other fraction. We can cancel out things that appear on both the top and the bottom. See? We have a bunch of 2s on top and 2 2s on the bottom. So we can cancel 2 of them out from both sides. Gone. And here's what we're left with. Now pay close attention to the bottom, the denominator. We still have those 2 3s and that 11 sitting there. Remember our goal? We need this whole thing to become a whole number, which means that denominator has to completely disappear. So how do we make it disappear? We have to cancel it out, right? And the only way to cancel out those factors on the bottom is if we have the exact same factors on the top to cancel them with.
And that leads us to this really clean, simple answer. Our mysterious number k, it has to be what's left on the bottom. It's the only way. K has to provide those missing 2 3s and that missing 11.
So there is, the identity of our mystery integer is finally revealed. K has to be 3 squared times 11. It's the one that brings the missing ingredients to the party. And what does that come out to? Well, 3 squared is 9, and 9 times 11 is 99. And there we have it. The smallest possible value for K is 99.
But, a good detective never closes a case without double-checking the evidence. We think the answer is 99. Let's plug it back into our original equation and prove it. Okay, so we're doing 392 times 99 and then dividing all of that by 396. The big question is, does it work? Do we get a nice, clean, whole number?
Yes, it works perfectly. The answer is 98. A perfect whole number, no decimals, no remainder. That's our proof. 99 is absolutely the right answer. We found K.
So let's just quickly run through what we did. We started with the puzzle, right? We used our prime factor tool to break the numbers down. We figured out exactly which factors K needed to provide. And then we checked our answer. A super logical way to solve it. Case closed.
And that's how you solve it. It's pretty cool, right? It just goes to show you that sometimes the most complex-looking problems can be solved by just understanding the basic building blocks. It kind of makes you wonder, what other mathematical puzzles are out there just hiding in plain sight, waiting for